Okay, in section 8.5, we're going to discuss the dot product of two vectors, which is going to give us a lot of useful information about the vectors. And so by definition, if we have two vectors, a1i plus b1j, and a2i plus b2j, then the dot product, and the way that this would be read as v dot w, is defined as the following. You multiply a1 by a2, so just as a heads up here, a1 is the ith component of v, and then a2 is the ith component of w. So you basically just multiply together the two first components, and then add and multiply together the second components. And one very useful product of this is the fact that we get to calculate the angle between two vectors using this formula right here. And this is going to be primarily calculator, but it could also be non-calculator. But you guys are going to be using your calculator to do this. Last two things, two vectors are said to be parallel if there is a non-zero scalar alpha, so that v is equal to alpha times w. And in that case, the angle between v and w is either 0 or 180 degrees. I had written pi there, but everything today is going to be in degrees, and so I'm going to change that to 180 degrees. And so just to give you a basic example of what we mean here, if I have the vector v, which is 1, 1, then an example of a vector that would be parallel to v would be like the vector 4, 4. And the reason v is parallel to w is because you can say that w is equal to 4 multiplied by v. And so the fact that you can say this, where alpha would be your 4 there, that is why the two vectors are parallel. And then finally, very important fact here is that if two vectors are orthogonal, if and only if their dot product is 0. And orthogonal is just another way of saying perpendicular in vectors. So perpendicular, orthogonal, pretty much talking about the same thing in that context. So in example 1, given the two vectors, we want to find the dot product, the angle between them, and state whether they are parallel, orthogonal, or neither. So in letter A, we have two vectors, v and w, and I find it really helpful to go ahead and just write this in a different notation. So for vector v, this is going to be the vector -1 and 1. And for w, we're going to have the vector 1 and -1. And so the first thing we want to do is we want to find the dot product. So v dot w, what we're going to do is we're going to multiply the first components together, so -1 times +1, and then we're going to add and multiply the second two components together, which for v would be 1 and for w would be -1. And when you calculate that, you're going to get, not 0, but you're going to get -2 for your dot product. Okay, for the second part, we want to find the angle between the two vectors. And so we know that the formula is going to be cosine theta is equal to, and if you want to come back up here and look at it, that's using u and v, but our letters are v and w, so I'm going to say v dot w divided by the magnitude of v multiplied by the magnitude of w. Okay, so probably what we want to do then is find the magnitudes of v and w, and so just doing some scratch work up here, I know that the magnitude of v is going to equal to the square root of -1 squared plus 1 squared, and so that's going to be the square root of 2. And then the magnitude of w is pretty much going to be the same thing. 1 squared is 1 plus -1 squared is 1, and so again I get the square root of 2. So what this is going to equal is -2 divided by the square root of 2 times the square root of 2. Okay, well, I know that square root of 2 times square root of 2 is just 2, so this is going to be -2 divided by 2, which ends up being -1. And so what I end up with is this statement that cosine theta is equal to -1. And so what angle has a cosine value of -1? Well, remember that cosine is the x-coordinate, and the x-coordinate is -1 over here at this point, -1 and 0, and that is the angle 180 degrees. And so that is going to be the angle between these two vectors of 180 degrees. And since the angle between the vectors is 180 degrees, which of course is a straight line, that means that these two vectors are going to be parallel. Okay, letter B, very similar problem here. So in the first step, we're going to find the dot product. And again, it might be helpful and useful to write this in some different notations. So 1 and -2 for W. And so whenever I do V dot W, this is going to equal to 2 times 1, which is 2, plus 1 times -2, which is -2, and 2 plus -2 is equal to 0. Now, there's a couple of things that follow immediately from this fact, and the first one is that these two vectors are orthogonal. And we can refer back to our facts back here in the notes, specifically this thing that I starred right here, that because the dot product is 0, we say that the two vectors are orthogonal. And then secondly, because they're orthogonal, remember that means perpendicular, and if you'll remember what perpendicular means, it means that there is a right angle between them, and therefore the angle between these two vectors, without having to do any calculations, I know it has to be 90 degrees. Okay, in letter C, we've got this strange V, and then W is -I minus J, so V is going to equal to -square root of 3 and -3, and W then will be -1 and -1. And so the first thing we want to do is find the dot product, V dot W, which is going to be the first two components multiplied together, -√3 times -1, which will be √3, and then plus the second components multiplied together, -3 times -1 is +3, and there's really no way to simplify that, so I'm going to move on to the next part, which is to find the angle between these two vectors. So I know that cosine theta is going to equal to V dot W divided by the magnitude of V multiplied by the magnitude of W. Okay, well, from the first part, I know that V dot W is the square root of 3 plus 3. And now I need to calculate what the magnitude of V and W are. So the magnitude of V is going to be the square root of the first component squared, and -√3 squared is just regular 3, plus -3 squared is 9, and that's going to give me the square root of 12. And so down here I'm going to have square root of 12. And then the magnitude of W will equal to the square root of -1 squared, which is 1, plus -1 squared, which is again 1. And so this will be the square root of 2. And so down here I will have the square root of 2. And so therefore, this is going to be a calculator question. Theta is going to be cosine inverse of that strange number there, √3 plus 3, divided by √12 times √2. And make sure your calculator is in degree mode when you do this. And if it is, then what you're going to get as the answer is 15 degrees. Now, because the angle between the two vectors is 15 degrees, that means they're not parallel, because in order to be parallel, that would be like letter A here, where the angle was 180 degrees. They're not orthogonal, because in that case, the angle would be 90 degrees. And so therefore, these two vectors are neither orthogonal nor parallel. So you would just answer neither for the third part there. Okay, I'm going to give you a chance to do letter D on your own. And so go ahead and pause the video and come back and I'll have the answers written for you. And so here we go, V dot W, hopefully you got 0. Secondly, that means that the angle between the two vectors was 90 degrees. And thirdly, if the angle is 90 degrees and the dot product is 0, that means that the two vectors are orthogonal. Okay, in example 2, interesting problem here. I like this problem. It says find A, and so what is it talking about? It's talking about this A right here, so that the vectors are orthogonal. And so I need to refer back to the definition of what it means for two vectors to be orthogonal. I know that that means that their dot product is equal to 0. Okay, so for this particular problem, we have this vector V, which is equal to 1i minus aj, and we have a vector W that is equal to 3i plus 3j. And so whenever I do the dot product, v dot w, then I'm going to multiply the first two components together, which would be 1 times 3, so 3. And then negative a times 3 will be negative 3a. And if I want these vectors to be orthogonal, I need to set the dot product equal to 0. And so if you go ahead and solve that for a, you're going to get 3 is equal to 3a, so that 1 is equal to a. Okay, last two examples. We're going to talk about how to decompose a vector v into two different vectors, one of which is parallel to a given vector w, and the other of which is orthogonal to a given vector w. And so the formulas are given right here. You don't need to memorize them. I'll be happy to give them to you and let you use them on the test. So there they are. We just need to know how to use them. So the first thing that might be helpful is just to, again, rewrite these in a different notation. So this is going to be the vector 1, 3, and w, of course, will be the vector 1, 1. And so what we're after, first of all, is v sub 1, which is going to be a vector that is parallel to w. And so the formula is given right back up here. It is v dot w divided by the magnitude of w squared, and then multiply that by w. And so the first thing we want to figure out is what is the dot product. So the dot product is going to be the first components multiplied together, which will give me 1, plus the second components multiplied together, which will give me 3, divided by the magnitude of w squared. Okay, well, what is the magnitude of w? It's the square root of 1 squared plus 1 squared, which is going to be the square root of 2. And so the square of the magnitude of w is just going to be 2. And then I'm going to multiply this by w, which is the vector 1, 1. Okay, so doing some simplifying here, 1 plus 3 is 4 divided by 2 multiplied by 1, 1. And so this will be 2 times the vector 1, 1, which of course will just be the vector 2, 2. And writing that in the other notation, that's going to be 2i plus 2j. Okay, once you have v1, you are now able to find v2, which is just going to equal to your original vector subtracting v1. And so this is going to equal to our original vector of v, which is the vector 1, 3, and then subtracting our v1 vector that we found in the first part of this question. And so when I subtract vectors, I'm just going to subtract their respective components. And so if I look at the first components, 1 minus 2 is negative 1, and 3 minus 2 is positive 1. And so therefore, this is going to be the vector negative I plus j. Okay, so that'll do it for example A. I'm going to let you try example B by yourself, and then I will give you the answers after you pause the video and give it a shot. Okay, for letter B, here are your answers. You've got v sub 1, which is going to equal to negative 3 halves I minus 3 halves j. And v2 is going to equal to 5 halves I minus 5 halves j. So if you have any questions about that, please feel free to ask.